Okay, good afternoon students. Today we are going to start the another topic of crystal field theory is factors affecting on magnitude of 10 dq value. In last lecture we saw the how the spectra use to measurement of 10 dq value. We discuss it as well as we discuss the evidences of existence of CFAC in a complexes. So evidence is in a CFAC, evidence of CFAC in a complexes. For that we specially consider the two energies, hydration energy and lattice energy. Okay, after that we solve the problems, we can find out, we calculate the 10 dq value of the complexes once we have the absorption band of the complex. So using absorption band we can find out the 10 dq value. After it, the next point is factors affecting on magnitude of 10 dq value. So, which are the factors are responsible for the variation of 10 dq value by complex? So, every complex has different value of 10 dq. So, which are the factors responsible for it? We are going to discuss here. Basically, there are three factors are responsible for the 10 dq value. The first factor is nature of ligand. Second one is charge on the metal ion. Third one is position of metal ion in a transition series. Means in a complex the ligands are present. In a complex the particular metal ion is present. So metal ion has oxidation state, means there is a positive charge on it. So some complexes has +1 charge, +2 charge, +3 charge. So there are different type of charges are possible depending on the how many electrons are lost during the formation of complex. So in that point we are going to discuss here how nature of ligand influence on the 10 dq value. So we are going to discuss first nature of ligand. So there are 4 examples are given to you. In all 4 examples, the central metal ion has same oxidation state, same metal is present, chromium present here in a +3 oxidation state in all the 4 complexes, and their 10 dq value is measured here, which is given to you. So in first CrCl6 3 minus, the 10 dq value is 163 kilojoule per mole, while in CrCn6 3 minus, the 10 dq value is 314 kilojoule per mole. Means if we observe, the 10 dq value increases from top to bottom. So question is, why in first case the 10 dq value is lower while in last case the 10 dq value is higher? So why this observation is shown by the complexes? The reason is basically, you know, the 10 dq value depends on how the ligands are responsible for this splitting. If splitting is more, that means the 10 dq value increases. If splitting is lower, that means 10 dq value decreases or lower value. So those complexes which shows stronger splitting shows higher value of 10 dq, or other side the complexes which have lower splitting shows also lower 10 dq value. So splitting is depends on the interactions of metal electrons and interactions of ligand. If ligand is powerful, it is more interact, more come close to the metal nucleus, and the result is there is a more repulsion. So to avoid this repulsion, metal orbital itself split their orbitals into two energy state, Eg set and T2g set. So Eg set and T2g set when further split here, if ligand is stronger, this splitting is more powerful. So the 10 dq value is higher. So this splitting is totally depends on ligand. So here in the given consideration, here we consider same metal ion, we consider same oxidation state, just change the ligands here. So ligand is in first case Cl, then water molecule, then NH3 molecule, then Cn molecule. So according to it, Cl is a stronger ligand. It is come more close to the metal ion, and if come close, suppose here is a metal, here is a ligand. So when on first donation there is a formation of metal ligand coordinate bond. So if ligand is stronger, if ligand is stronger, it come close to the metal. Metal has some electrons here. Metal has some electrons are here. So the ligand electrons and metal electrons are make a repulsion, and to better stability it is very important to avoid or to minimize the repulsion between the metal ion and ligand. So that's why metal d orbitals are split into two energy states. Here is the T2G and here is the EG. So this splitting totally depends on nature of ligand. If nature ligand is powerful, it produces stronger splitting. If ligand is weaker, it produce lower splitting because there is less interaction. That means there is no need of higher splitting. But if ligand is stronger, there is a need of higher splitting. So that's why if nature of ligand is increases, as their strength is increases, so stronger ligand produce more stronger splitting, and if there is a more stronger splitting, that means there is a higher absorption between the two energy states. That's why there is an absorption band also higher and their 10 dq value also higher. So nature of ligands is predicted, or all the ligands in arranged in a particular series according to their strength, and the series called as spectrochemical series. The series called as spectrochemical series. That means if we consider same metal, same oxidation state, we just replace the ligands. Every ligand has different tendency of absorption of light. Absorption band shows different absorption band. So those ligand which shows higher absorption band, which are considered as a stronger ligand, त्याला आपण म्हणतो stronger ligand. So the spectrochemical series we will discuss in later part of the chapter. The ligands are arranged in a such way that their tendency to increase the 10 dq value. Spectrochemical series means the chemical nature of ligand influence on the spectra of the complex. That's why called as spectrochemical series, and the series is the arrangement of ligand according to their absorption band. So this is the first factor we consider here, is the nature of ligand. So stronger ligand will absorb the higher absorption band and shows higher 10 dq value. So Cl as compared to Cn, Cn is a stronger ligand, Cl is a weaker ligand. So that's why their 10 dq value is lower as compared to Cn minus, because Cn minus is a stronger ligand. It is the first point. Okay. What is the second? The second is, it is a first. Second is charge on metal ion. Second is charge on the metal ion. So there are three different conditions we consider here, because of the charge may be same but metal is different. It is a first condition is possible. Okay, second is metal is same, charges are different. It is another condition. So we are going to discuss all the conditions here, and then we going to understand how 10 dq value is variable. So A part is, first is, this is a different charge on metal, different charge on metal of same metal. So metal is same, but what is the difference? The charge is different. So here we consider Cr H2O6 2 plus. Second example is Cr H2O6 3 plus. Okay, so there are two examples here we consider. Metal is same metal, ligand also same, because ligand also influence on 10 DQ value. So here we just, what is the difference? Here is a plus 3, here is a plus 2, water is neutral. That means here Cr present in plus 2 oxidation state, here Cr present in plus 3 oxidation state. So same metal having different charges. So in that case, in which case there is a higher absorption of the value? So it is very simple. Look at here. Suppose you imagine there is a Cr2 plus and Cr3 plus. Metal having higher nuclear charge means plus 3 is the nuclear charge on the metal and here plus 2 is the nuclear charge on the metal. So in which case ligands are more attracted towards the metal ion. So higher nuclear charge, that means it is a more positive side of the metal. So ligand which are coming from other side are more attracted towards it because higher positive charge here as compared to first one. So in second case there is a more attraction between the metal ion and ligand as compared to first one. So their result is what happened. If you understand here, if in second case ligands are more tightly attracted with the metal ion, that means their interaction means interactions of H2O and the remaining electrons of Cr, their interactions are more powerful in second case as compared to first one. So if there is a more interactions, that means it is possible to higher repulsion. So to avoid this higher repulsion due to ligand come close more come close towards the metal ion as compared to first one. So to avoid this repulsion, metal d orbital itself undergoes splitting. But as compared to first one, there is a higher attraction, higher repulsion, higher interactions. So that's why when these two d orbitals are splitted, that time in second case the splitting is more powerful, higher splitting is observed because of in second case, in which case there is a higher oxidation state case, the ligands are more attracted. That's why there is a more interactions, and to avoid more interactions, repulsion between the metal electrons and ligand electrons, metal d orbital undergoes splitting and the splitting is more effective as compared to first one. So the complex, the metal ion which having oxidation, higher oxidation state, same metal but having the different charges. So the higher charged metal ion will absorb the higher light absorption frequency as compared to this one. So here is a higher 10 DQ value as compared to first one. So the values are given here 39.7 kilocalorie and in second case it has the 50.94 kilocalorie. So why this observation is observed? Because of these values are different. Here is a higher 10 DQ value because of due to higher charge on metal ion, ligands are more attracted. So it is the first condition because the point is charge on metal ion. So in first case we just discussed metal ion is same but charges are different. In second case different charges on the cation of different metals, charges are different and metal also different. So B is different charges on cation of different metal. So in first case the charges are different but metal is same, but here charges also different and metal also different. For that we consider here vanadium H2O6, here is a 2 plus and next one is Cr H2O6 3 plus. So means here vanadium present in plus 2 oxidation state, here chromium present in plus 3 oxidation state. So in that case, in which case there is a higher absorption, and geometry is same, it is octahedral, vanadium plus present in plus 2 oxidation state, chromium present in plus 3 oxidation state, ligand is same. So different metal with different oxidation state, but ligand is same, geometry is same. So in that case, if you consider here electronic configuration is same, which electronic configuration? You know, vanadium has 23 atomic number, 23 atomic number, and if you write electronic configuration AR 3D 4s2, so here 4s2 3D 3 is the electronic configuration. For plus 2 oxidation state, these two electrons are lost, means vanadium present in which oxidation, what is the electronic condition? 3D 3. For chromium, there is chromium has 24 atomic number, AR 3D 4s1 3d5 is the electronic configuration, but what is the charge? Plus 3 is the charge. That means there is a need of 3 electrons are lost, 1 from here, 2 from here. So what remaining? 3d3. So here the condition to be considered, different metals with different charges but same electronic configuration. Which electronic configuration? Same system. Same system means d orbital having same number of electrons. Same number of electrons. So here 3d3, 3d3 means both having same number of electrons in a d orbital, but the charges and metal ion is different. So in that case, those metal ion which has higher the oxidation state, plus 3, here is a plus 2. So higher the oxidation state will absorb higher wavelength, higher frequency of light. That means there is a higher absorption band as compared to first one, because of higher charge will attract the ligands more towards itself as compared to lower charge. I already told you, we already discussed in first case. That means in second case there is a higher absorption frequency, so higher 10 dq value observed in case of second. The values are given here, 12,460 per centimeter. So here 10 dq value is not directly given, but the absorption band is also given, and you know, higher the absorption band, higher will be the 10 dq value. And in later case there is a 17,400 per centimeter is the absorption band. So it is clearly seen here, this in second case there is a higher absorption frequency, higher absorption band, that means higher the 10 dq value. So metal ion having the same electronic configuration but different charges and different nature, the metal ion which having the higher oxidation state will absorb the higher radiations. That means higher 10 dq value is observed in case of this. So here, but the necessary condition is, this one is very important, this should be same, this should be same. Okay, so the third possibility is, okay, the same different metals, different charges, but the electronic number is here, different is here. जर इलेक्ट्रॉन नंबर डिफरंट असेल तर काय? म्हणजे बघा की असं पण असू शकतं की पहिल्या केसमध्ये आपण पाहिलं की मेटल सेम आहे पण ऑक्सिडेशन स्टेट डिफरंट होत्या. ह्या केसमध्ये आपण बघतोय की मेटल पण डिफरंट आहे, ऑक्सिडेशन नंबर पण डिफरंट आहे, आणि दुसरी गोष्ट काय की त्याचे इलेक्ट्रॉनिक कन्फिगरेशन आहे ते सेम आहे. मग तिसरी कंडिशन काय असू शकते बघा की मेटल सेम आहे, सॉरी मेटल डिफरंट आहे आणि ऑक्सिडेशन नंबर सेम आहे. म्हणजे मेटल हे डिफरंट असतात पण ऑक्सिडेशन नंबर सेम आहेत, लिगॅन पण सेम आहे. कारण की आतापर्यंत मी तुम्हाला हे एक गोष्ट सांगितली की ज्याच्यावरती हायर चार्ज असतो त्याच्यामध्ये हायर 10 dq व्हॅल्यू असतो. पहिल्या केसमध्ये पण पाहिलं आपण, सेकंड केसमध्ये पण पाहिलं. पण जर ऑक्सिडेशन नंबर सेम असेल, ऑक्सिडेशन स्टेट सेम असेल पण मेटल डिफरंट असतील, म्हणजे लिगॅन पण सेम आहे, ऑक्सिडेशन नंबर पण सेम आहे, पण मेटल डिफरंट असतील तर काय? वी गोइंग टू डिस्कस इन थर्ड पॉइंट. Same charges, third point, same charge on different metal ion, same charge on different metal ion. For that we consider here CO H2O6 2 plus, second one is Ni H2O6 2 plus. That means here cobalt exists in 2 plus oxidation state, Ni exists in 2 plus oxidation state. Means same oxidation state but different metal ions. And you know, if there is a different metal ion with same oxidation state, definitely their electronic configuration in D system is always different. Oxidation state same आहे पण जर मेटल डिफरंट असेल ॲटॉमिक नंबर डिफरंट आहे तर डेफिनेटली त्यांच्या डी ऑर सिस्टीममध्ये डिफरंट नंबर ऑफ इलेक्ट्रॉन्स असतील आणि याला जर आपण कन्सिडर केलं इट शोज D7 सिस्टीम इट शोज D8 सिस्टीम पहिला दाखवतो D7 सिस्टीम आणि दुसरा दाखवतो D8 सिस्टीम इन दॅट केस व्हॉट हॅपन in that case what happen so where is the 10 dq value is higher and where is the 10 dq value is lower so a very important point is here those metal ion having same electron same ligand same oxidation state but there is a different number of electrons in a D system the metal ion which has lower number of electrons which having the lower number of electrons in a D system will absorb will shows higher the 10 dq value higher the 10 dq value that means suppose you consider here a splitting of both okay 7 electrons and here is a water so field is same strong or weak okay so if 1 2 3 4 5 6 and here is a 7 okay in later case 1 2 3 4 5 6 7 8 so here for nickel here for cobalt in which case there is a more absorption so in first case there is a more absorption why because here all the electrons are paired and to promote electron from this level to this there is a need of to destroy to break the pair that's why more energy is required to break it more energy required to break it so that's why their absorption is lower their absorption is not effective आता तुम्ही म्हणा एनर्जी जास्त लागणार त्याला ब्रेक करण्यासाठी easier absorption होणार नाही but here is a more easier absorption that means this electron absorb radiations frequency is more so it is because it is very easily transferred here so in that case the system which having more electrons will absorb the lower value or the system having the less electron absorb the higher value you can write anyway the electronic system which having the higher number of electrons will absorb the less value of 10 dq or the system which having the lower number of electron will absorb will shows higher the value of 10 dq so here this shows higher 10 dq value and here the value is 9300 per centimeter here 8500 per centimeter so this is the reason in first case higher value because lower number of electrons so if the same oxidation state same nature of ligand if the systems are different that time lower electronic system will absorb higher absorption band that means shows higher 10 dq value so it is the second factor is the charge on metal ion it is a charge on metal ion there are three conditions we discussed here and third factor is what is the third factor position of the metal ion in a transition series so third is here position of metal ion in transition series and you already know there are three transition series first transition series second transition series third means first transition series has 3d orbital second transition series has 4d orbital third transition series has 5d orbital okay suppose there are three examples are given to you the metal ion has same oxidation state same nature of ligand but the metal ions are belongs from one from first another from second next one is from third so for that here examples are given CO H2O6 3 plus second one is given it is the rhodium sorry here we consider NH3 rhodium NH3 6, again 3 plus, next one iridium, NH3 6, 3 plus. That means here same oxidation state, same nature of ligand, but cobalt belong from first series, rhodium from second series and iridium from third series. So in which case there is a higher absorption. So basically when we move from top to bottom, size of d orbital increases. Size of d orbital increases means here we observe this is the order. 5d is more having the size as compared to 4d, 4d having more size as compared to 3d. So if higher the space of the d orbital, it shows higher splitting. It shows higher splitting. So 5d split very easier due to higher size as compared to 4d. 4d split higher as compared to 3d. So when we move from top to bottom within a period, within a group, that time the higher transition series metal ion will absorb the higher absorption band, means shows higher 10dq value, and from first to second it increases up to 30 to 40%. 30 to 40% increases in a 10dq value as compared to 3d. From second to third it will be increases up to 20 to 30%. म्हणजे पहिल्यापासून सेकंडपर्यंत जाताना 30 to 40% व्हॅल्यू इन्क्रीज होते. ओके, सेकंड टू थर्ड मध्ये जाताना 20 to 30% व्हॅल्यू इन्क्रीज होत जाते. अँड द व्हॅल्यूज आर गिवन हिअर 23,000, 34,000 and 41,000 per centimeter. So here absorption band is given. Absorption band is given. If this absorption band is given, you can calculate 10dq value. The value is also given, but we already solved the two problems. So use these three values, you can solve the problems and find out the 10dq value in kilocalorie or in kilojoule. You can find out it is for exercise because the values are you have given here. So you solve three problems based on last lecture. The three values are given. You can find out the 10dq value using the last problem. Same as the last problem, the absorption band is given to you. So you can find out their 10dq value and you can check it. The values are given in book and the value you calculated using the last examples. So both are matching or comparatively close it. So you solve the problems. These problems it is for your homework. The absorption band is given, you can calculate 10dq value, measurement of 10dq value. So when we move from top to bottom, the 10dq value always increases within a group. आता एका ग्रुपमधला असेल, सपोज इथं असेल रोडियम आणि इकडे दिला असेल आयर्न, इकडे दिला असून तुमचा दुसरा दिला असेल प्लॅटिनम अँड ऑल, किंवा इकडं गोल्ड दिलेला असेल. सो कंडिशन इज ऑल द मेटल आयन्स बिलॉंग्स फ्रॉम द सेम ग्रुप. सेम ग्रुपमधले असतील तरच आपण त्याचं कंपॅरेटिव्हली स्टडी करू शकतो. सो दीज आर द फॅक्टर्स विच आर रिस्पॉन्सिबल फॉर द 10dq व्हॅल्यू. सो here we finish the factors affecting on 10dq value, and the last point is here we just discussed is CFT and magnetic property. CFT and magnetic property. What is the magnetic property? There are two types of magnetic property, which are diamagnetic and here is a paramagnetic. Okay, so diamagnetic and paramagnetic. If we consider the examples here for comparison, suppose you consider here Fe Cn6 3 plus, and here you consider Fe Cl6 3 minus. Sorry, 3 minus. So what happened here? Here is a cyanide, here is a Cl. Metal present in the same oxidation state, but it is a paramagnetic in nature. Here is the diamagnetic, because if you find here Fe26, so Ar 3d 4s2 3d2 4 3d6, so 4 minus आपण काय करू 4 minus घेऊया. Same. So here, what is oxidation state? In first case, there is a +2 oxidation state. Here also +2 oxidation state. So these two electrons are lost. Means D6 system is considered. So if we split here D6, for in that case cyanide is a stronger. So it possible here this type of splitting. 1, 2, 3, 4, 5, 6 because strong field ligand. But here what happened? 1, 2, 3, 4, 5 and then 6. So here there is no unpaired electron, but here 4 unpaired electrons. 4 unpaired electron means if any electronic system has one pair unpaired electron, we consider as a paramagnetic, while all electrons are pair we consider as a diamagnetic. So CFT is very important to know, is it the complex is paramagnetic or diamagnetic. So we split here according to the field, it is a strong or weak, and then we observe, is it any unpaired electron present or not. If all electrons are paired, that means here is the diamagnetic. If all electrons are, one of the electron is unpaired, that means it is a paramagnetic. So here what happened, it has 4 unpaired electrons. It has 4 unpaired electrons, and we can calculate the magnetic moment using the spin only formula. The formula is under root n plus 2. Under root n plus 2 is the formula which is used to calculate the magnetic moment. So here n is the number of unpaired electron. So for that there is a 4 unpaired electron. That means here 4 into 4 plus 2. So here under root 24 and the value is, it is a 4.92 Bohr magneton. It is a 4.92 Bohr magneton. So this way we can calculate, we can find the complex is paramagnetic or diamagnetic. So CFT is helpful to know the value of magnetic property, but it is the not accurate, because of to know the accurate value of the magnetic moment we mostly consider the experimental values, and there are the theoretical values which are considered, which are calculated using the presence of unpaired electron. So this is all about the today's lecture. So important is factors affecting on 10dq value. First we discuss the nature of ligand. Second we discuss the charges on the metal ion. In that we consider the three condition, means same metal having the different charges. Okay, different metal having the same charges, and third case is different charges on different metal ions but the electronic configuration is same. So in that case, in which condition there is a higher 10dq value and which condition there is a lower 10dq value we discuss here. After that we discussed the magnetic property, means those fields. So basically weak field complexes are mostly paramagnetic as compared to strong field complexes, or if strong field complex also paramagnetic property but their value is lower as compared to weak field complexes, because in weak field complexes there are more number of unpaired electrons because there are high spin complexes. But in a strong field complexes there is a less number of unpaired electrons. This means we consider as a low spin complexes, or spin paired complexes, as spin free complexes. Okay, so ionic, covalent, low spin, high spin, spin paired, spin free. These are the distinguishes which are considered by in a different conditions. So this is all about the today's lecture. In next lecture we are going to discuss the very important point of crystal field theory is there is a distortion in octahedral complexes. John Taylor distortion. Distortion means what? We are going to discuss in next lecture. It is the changes in the geometry, means regular geometry is distorted along the x-axis or along the xy axis, along the xy axis or along the z axis, means it is not regular, means bond length on axial and equatorial positions are different. This is the distortion. If all the bond lengths are same, it is a regular geometry, but if the geometry is distorted along the z axis or along the xy axis, why this happen, we are going to discuss in our next lecture. So we stop here.